All right, let's get to part two of this. So, we're going to be talking about environmental consequences of nuclear power. So, um, some good consequences. So, for air, there is no air pollution from nuclear power plants, and that's unless they melt down. If they melt down, then as you saw here, there are some air quality problems. That's mostly with radiation and fallout being spread through the atmosphere through our currents. Um, there is some pollution from the mining of the materials for nuclear power. So uranium is what we're mining. Um, there's, I'll talk about it at the end of this PowerPoint, but every time you mine something, it's going to damage the environment at least a little bit. So then, water. They use a lot of water for nuclear power. As we saw here, they're constantly sucking water in, heating it up, and then putting it back into the environment. But there's a certain point, like right here, where that water is not in the environment. And then when it pops out, it's too hot to be used for that same environment. So we're actually taking away water from the environment. Even though it looks like we're putting it back in, we're constantly taking out. So through this whole like 5-step process, water is not being used in the natural realm. So it's only being used here. So that's something to think about. Um, so there's huge water requirements, approximately 476,500 gallons per minute needed to run one of these suckers. So that's quite a bit. Um, you know, 476,000 gallons per minute is a lot, and that's how much is like being taken out of the system. Yes, they put it back in, but it's not ready to be used right away. So technically, it's a renewable resource that is being turned into a semi-non-renewable. So used water is returned to the environment altered, and that's like I was talking about, it gets hot, and that will negatively impact aquatic ecosystems because you have like little bugs in there that if you raise the temperature 2 degrees, they'll die. So, and those bugs are used for all the other animals in there. It's called the food chain. So the bottom supplies energy to the top. So that's something to think about. You can't just not think about organisms dying because that's where the energy flow is going from system to system. So a lot of people don't care about animals, but they don't understand how necessary they are to our being able to survive on this planet. So uranium mining and its disposal can infiltrate waterways. A good example of this is there's a big uranium deposit site in Moab, Utah. It's right next to the Colorado River. Um, so if there's any sort of leak that's going to get into the Colorado River, the Colorado River supplies 1/4 of all of the water. The Colorado River watershed supplies 1/4 of all of the water for America's needs. So if we get a uranium contamination through the Colorado River, we're talking about like Colorado, Nevada, California, New Mexico, parts of Texas, they won't have water to use. So that's a really big deal. So there is a site next to the Colorado River in Utah. They're currently trying to move the uranium deposits. So there's always a risk in that. When you move something, there's a chance for a leak or something to spill because humans screw up all the time. You have to always take into account the human effect of things. So, while it may seem like a good idea to move this stuff, it's right next to a river and people are going to be touching it. And people screw up, and there's a chance that that uranium could leak into the Colorado River, and that would kind of destroy that whole waterway for a good amount of time because it's going to be hard to clean that stuff up. So continued, the amount of land that is required for nuclear plants is very, very small. So you preserve habitats that way. You're just, you're not mining, you're not contributing to deforestation. You have a plant, it sucks up water, and that's it. So another thing is uranium's a non-renewable resource, so we only have so much of it, and that's what we use to power a lot of those plants. So uranium must be mined and refined, and the Environmental Protection Agency estimates that the United States has huge reserves of uranium totaling about 890 million pounds. So, we have a good amount. We don't need to keep mining that stuff right now, but eventually it will go away. It's a non-renewable. So, that stuff doesn't just like pop up. It takes millions of years to turn into uranium. and then B, the certain uranium that we use for nuclear reactors. So the last thing is the storage of radioactive waste is a huge concern. So we have this mountain. We have one site in America called Yucca Mountain. Basically, we drilled a huge hole down into the middle of it. We made a subsurface mine with columns and ceilings, and we just kind of put all the nuclear waste down under this mountain. So the problem with that is not only is that going to fill up at some point, but we need to transport waste across states to get to Yucca Mountain, which is in Nevada. It's northwest of Las Vegas. So states don't really like the idea of having people transporting nuclear waste across their state lines. You know, what if there's a car accident? You know, there's some sort of accident happens, and all that nuclear waste spills into your state. Your state's screwed. So you know, there's a lot of risk there. Like I said, humans screw up. It just happens. So here's Yucca Mountain. Here's the entrance. They just take huge trains into here. You see this little like air vent because this thing goes deep. So trains come in filled with nuclear waste, and then they fill that sucker up. Here's the repository. Like it's like a mile down. They've got a couple entrances, and then here's the mountain itself. And then what's important here is they've got bedrock, and then more bedrock, and then another layer of bedrock, and then there's the water table. So there's not a very good chance of any of this nuclear waste spilling down through the bedrock into the water table. There's a lot of things that are stopping that nuclear waste from getting to the water, so that's why they used it. So some economic consequences of nuclear power. Electricity supply and economic growth, that's number one right there. It's amazing for electricity. So nuclear power, this is a quiz question, is the lowest cost energy producer by far. So we get 1.8 cents per kilowatt hour of nuclear energy, which is incredible. Coal is about 2.75 cents per kilowatt hour. Natural gas is 8 cents, and oil is a whopping 17 cents. So we use natural gas and oil a lot here, and coal as well, but the world is kind of going away from coal because it's not very clean, it's not good for the environment, it's just really cheap. Affordable electricity helps keep costs down and keeps American businesses competitive. So with using this really good, low cost energy, we're going to keep businesses afloat. You know, have you ever heard the term like keeping the lights on? That's because energy right here, 8 cents per kilowatt hour, is really expensive. So plants provide employment opportunities as well. So the only problem is that there's a really, really large cost of construction, and they take a long time to make. So we're a little behind the game already. So 2 advanced nuclear reactors cost about $14 billion, and they take like 10 to 15 years to make. So, you know, if we want to really start making a difference, we should have started about 10 years ago to make a bunch of nuclear power reactors. Making them 10 years in the future isn't really going to help us for the next 10 years. But I say start now, might as well. Current estimates say that the United States needs to invest about $1.5 to $2 trillion in new plants to provide enough energy for future needs. The only thing about this $2 trillion is once we've completed the building of these nuclear reactors, they only give back money. So this will quickly go down. After about 5 to 10 years, we'll make our money back from nuclear energy. So the thing we need to talk about is safety and security, because we know meltdowns happen, and there's a large amount of like terrorism going on all throughout the world. So they've really changed their operational safety, their plant security, and their emergency preparedness, especially since 9/11. So reactor safety, radiation safety, and security are all regularly monitored and posted for public viewing. So you know, we've got people checking on these things. Personnel go through rigorous trainings, background and criminal history checks. Security has increased massively around nuclear power plants, and they all have detailed emergency response plans now. We've screwed up enough times to where we've got a pretty good system going. So here is the security. We've got a nice big fence that no one can get in. We've got security officers around the fence. You need to have access to get into the fence. Then there's roving patrols in the middle with guard towers, intrusion detection systems all around the fence line. There's a water barrier around this as well. So normally like 3 Mile Island had all those rivers around it. And then you have to get into the plant itself. So there's a lot of stuff that you need to do to be able to get in and screw around with a nuclear power plant. So the last thing we're going to talk about is food, food and nuclear power. So food irradiation was approved by the FDA to use on fruits, veggies, pork, poultry, red meat, and spices. So pretty much everything. What they do is they expose food to gamma radiation, and that's gamma radiation through cobalt-60 or just electron beams. So they just zap this food with gamma radiation, and that's necessary to kill bacteria, insects, and parasites that cause 75 million illnesses and 5,000 American deaths annually. So that's a lot of stuff that's getting kind of, this stuff is getting killed so that we don't have these 75 million illnesses and 5,000 deaths annually. It's still going to happen because people choose, organic or whatever. That's fine. That's a lifestyle choice. There's no problem with that. What irradiation does is it slows down spoilage, it increases the shelf life, and it makes cheaper, more available food. So in the long run, it's a really good thing. The FDA has looked at numerous studies on mass populations and irradiated food and haven't found any negative side effects yet. So it's safe to say that irradiated food is okay to be eaten as long as it's exposed properly. So like I said, humans screw things up, so there's always that chance of, somebody in a radiation factory putting too much onto something or, putting it onto the wrong food, all that type of stuff. So, it is important to make sure you know where your food's coming from and just check, check the news on food. A lot of the times there's going to be warnings out and recalls out that we might not know about if we don't check. So it's always important to check that type of stuff. Honestly, in today's society, you can become educated and pretty much an expert on almost any topic as long as you're going through the right avenues. So if you are able to find correct sites that are peer-reviewed, don't display too much false information, then you can really become educated really quickly. So it's on us to make sure that we don't always believe everything that we hear. So, if you guys fact check me and you find something that I said is wrong, tell me. That's awesome. That's what science is all about. So with science, you're always trying to prove something wrong. You can never prove something right. That's like the whole deal with science. So there's kind of a misconception that scientists are always proving things right and they use 100% statistics. That's not true. We never use 100%. We never prove anything right. It's always about proving things wrong. So if you're not able to prove a thesis wrong or a theory wrong, then that's when it becomes validated a little more. So that's what we're doing with trend lines with carbon dioxide and temperature, where we don't prove anything right, but we haven't proved ourselves wrong yet that this trend line is showing an increase in temperature with an increase in carbon dioxide. So that's just a good example of that. Make sure you stay informed. That's my last little lesson here for this subunit. Just stay informed. We need everyone to stop being able to just inhale information from sources that we haven't checked on yet. So make sure you don't just believe everything you hear or see on TV. Other than that, that's the end of this unit. Have a wonderful day, and let me know if you need any help, and I will help you out with anything you need.